This is my third video lesson for Unit 14. In this lesson, we'll be writing half reactions. Go to page 12 in the class packet. Let's answer the questions in the motivation. What is transfer in a redox reaction? Electrons, the atoms being reduced, gain electrons, atoms being oxidized, lose electrons. The charge of electron is -1, mass of electron is close to 0. All chemical reactions must be balanced for mass, charge, and energy. Learning target. At the end of the lesson, I'll be able to write half reactions given a redox reaction. Homework be number 3, which be a junipod based off this lesson. A half reaction is either the oxidation or reduction reaction component of a redox reaction. So a redox reaction has two half reactions. One is oxidation and the other is reduction. In order to write the half reaction, we must figure out where to put the electrons in the chemical equation. Let's look at the first example. Here we have iron 0 becoming iron 3+. This is oxidation because the oxidation number is becoming more positive. Electrons is lost in this reaction. Therefore, electrons are on the product side. Since it goes from 0 to 3+, we have 3 electrons that is lost in this reaction. Let's look at another example. Here we have silver +1 becoming silver 0. This is reduction because the oxidation number is becoming smaller. Electron is gained during this reaction. Therefore, the electron is on the reactant side of the equation. Since silver goes from +1 to 0, only 1 electron is gained. So here's some catchphrases to help you memorize how to write the oxidation and reduction half reaction. For the oxidation half reaction, losing electrons, write electrons last. Reduction, electron is the reactant, reduction. Remember to include the sign for electrons. Electrons have a charge of -1. Let's look at 4 different scenarios. Scenario 1 and 2 are the most common on the Regents exam. Given the following redox reaction, write the oxidation and reduction half reaction. The first step is to figure out which element is being oxidized and which one is being reduced. By looking at the redox reaction, nickel is being oxidized and copper is being reduced. So let's write nickel first. Nickel is going from nickel 0 to nickel 2+. It loses 2 electrons, so we write the 2 electrons on the product side. For copper is going from copper 2+ to copper 0. It gained 2 electrons, so we write the electrons on the reactant side. Notice in both half reaction, the law of conservation of charge is observed. The charge of the reactant side is 0. The charge of the product side is also 0. If we combine both half reactions, we get back the original redox reaction. So in this redox reaction, there's a transfer of 2 electrons. The nickel loses 2 electrons, and the copper gains 2 electrons. In each equation, the law of conservation of mass and charge is observed. Learning check number 1. Which half reaction correctly represents oxidation? Pause the video and resume as completed. For oxidation half reactions, you write electrons last, so choice 2 and choice 4 are wrong. Choice 1 is also wrong because conservation of charge is not observed. The charge of the reactant side is 0. The total charge of the product side is -4. So choice 1 is wrong. Choice 3 is the best answer. Learning check number 2. Which half reaction correctly represents reduction? Pause the video and resume as completed. For reduction, electrons are on the reactant side. Choice 1 and choice 4 are wrong. Choice 3 is also wrong because conservation of charge is not observed. The total charge of the reactant side is -4, and the charge of the product side is 0. So choice 3 is wrong as well. The answer is choice 2. Learning check number 3. In the reaction, the silver plus is what? Pause the video and resume as completed. The silver is going from +1 to 0, so it is reduced. Answer is choice 1. Learning check number 4. Which half reaction equation represents the reduction of potassium ion? Pause the video and resume as completed. In reduction, electron is on the reactant side, so choice 1 and choice 4 are wrong. Choice 2 is also wrong because conservation of charge is not observed. The total charge of the reactant side is -1. The total charge of the product side is +1. So choice 2 is wrong as well. So the answer is choice 3. Learning check number 5. Given the cell reaction, the reduction half reaction for the cell is what? Pause the video and resume as completed. The first step is to figure out which element is being reduced. It is lead. Lead goes from 2 plus to 0. So the answer is choice 1 because for reduction half reaction, electron is on the reactant side. Now let's look at scenario 2. In scenario 2, it is slightly harder because there are coefficients that are not 1. The first step in writing a half reaction is to figure out which element is being oxidized and reduced. Lithium is being oxidized and magnesium is being reduced. So let's first write the oxidation half reaction first. Lithium is going from 0 to +1. It loses 1 electron, so the electron is on the product side. For the reduction half reaction, magnesium goes from +2 to 0. It gains 2 electrons, so electrons are on the reactant side. Notice the reduction half reaction has 2 electrons, but the oxidation half reaction has 1. Therefore, you can double the oxidation half reaction so that it has 2 electrons. If you were to combine these two half reactions, you will get back the original redox reaction. You can write either one of these half reactions for oxidation. Either one is fine for the Regents exam. In all these equations, the law of conservation of mass and charge is observed. Learning check number 6. Given the equation, the reduction half reaction is what? Pause the video and resume is completed. The first step is to figure out which element is being reduced. It is copper. It goes from copper 2 plus to copper 0. It gains 2 electrons. In reduction, electrons on the reactant side, so the answer is choice 2. In scenario 3, you have compounds now. Let's first figure out which element is being oxidized and reduced. Magnesium is being oxidized because it goes from 0 to +2. Oxygen is being reduced. It goes from 0 to -2. Let's first write the oxidation half reaction. Magnesium goes from 0 to +2. It loses 2 electrons. Therefore, the electrons are on the product side. For oxygen, it gains 2 electrons. It goes from 0 to -2. Since there's 2 oxygens, a total of 4 electrons is gained. So we write 4 electrons on the reactant side. Notice the oxidation half reaction has 2 electrons, but the reduction half reactions have 4 electrons. We can double the oxidation half reaction. If we combine both of these equations, we will get the original redox reaction. For the Regents exam, you can write either one for the oxidation half reaction. All of these chemical equations follow the law of conservation of mass and charge. Learning check number 7. Given the reaction, which half reaction correctly represents the reduction that occurs? Pause the video and resume as completed. The first step is to figure out which element is being reduced. It is chlorine. It goes from 0 to -1. So the best answer is choice 2 because electrons are on the reactant side for reduction half reactions. Learning check number 8. Given the reaction for the corrosion of aluminum, which half reaction correctly represents the oxidation that occurs? Pause the video and resume as completed. The first step is to figure out which element is being oxidized. It is aluminum. It goes from 0 to +3. For oxidation half reactions, you write electrons last, so the answer is choice 2. For the last scenario, the redox reaction will contain elements that will not be reduced or oxidized. So the first step is to figure out which elements are being oxidized and reduced. Copper is being oxidized. It goes from 0 to +2, and silver is being reduced. It goes from +1 to 0. The nitrogen and oxygen is not being reduced or oxidized. Let's first write the oxidation half reaction. Copper is going from 0 to positive 2. It loses 2 electrons, and electrons are written on the product side. For the reduction half reaction, silver goes from positive 1 to 0. It gains 1 electron and is written on the reactant side. Since the oxidation half reaction involves 2 electrons and the reduction half reaction involves 1 electron, we can double the reduction half reaction. Either one is fine for the Regents exam. What will you classify nitric ion as? In the redox reaction, the nitrogen-oxygen did not change oxidation numbers. Therefore, nitric ion can be classified as a spectator ion. Learning check number 9. Given the reaction, which equation represents the correct oxidation half reaction? Pause the video and resume as completed. The first step is to figure out which element is oxidized. It is zinc. It goes from 0 to positive 2. In oxidation half reactions, electrons are written on the product side, so the answer is choice 1. For practice 1 and 2, write the oxidation and reduction half reaction given the redox reaction. It goes from easy to hard. Try to do this yourself, pause the video, and resume as completed. Here are the answers. This concludes the video lesson. Remember to do the JunaPod homework.